realize the given difference. This is a given difference equation. For this given difference equation, we have to realize the circuit using direct form 1 as well as the direct form 2 structures. So these two structures has to be realized in order to realize our given difference equation in the circuit formation. Solution. The given difference equation is, write down the same and give it as equation number 1. Calculate number of, for this same problem, calculate the number of computations required in direct form 1 as well as direct form 2. So number of computations means how many number of additions are required, what are the memory locations, number of memory locations, how many multiplications are required. So we have to compare these values for direct form 1 as well as for direct form 2. Now the number of additions required in direct form 1 and number of additions required in direct form 2. So the formula is m plus n, and here also same m plus n. Number of memory locations in direct form 1 is m plus n plus 1. So what do you mean by m and n? Those are required number of delay elements in the input side as well as the output side. Then the number of memory locations in direct form 2, whereas the number of memory locations in direct form 2 is, the formula is maximum of m comma n. Given equation number 1, let us consider, this is for direct form 1 realization. So let us consider W of n is equals to entire input, present input as well as the past input values. W of n is equals to 2 into x of n plus 1 by 5 x of n minus 1 minus 2 by 13 x of n minus 3 plus 1 by 32 x of n minus 5. Now here we have present input, that is x of n, and these all are past input values. So in the past input values itself, we have x of n minus 1, n minus 2 missing, right? If n minus 2 is missing, then what is the coefficient? 0 is the coefficient. Then again n minus 4 also missing, that is the coefficient for x of n minus 4 is 0. Now give it as equation number 2. Now identify what is the input here for this expression. Input is x of n. What is the output? W of n is the output, right? Now input going towards the output side. If you are identifying the x of n, the coefficient is 2. Now first 1 by 5 the coefficient, but x of n minus 1. To generate x of n minus 1, x of n has to be goes to 1 delay. So it will produce x of n minus 1. What is the coefficient for x of n minus 1? 1 by 5. Again to generate x of n minus 3, right? So this x of n minus 1, from the delay property, it has to be goes to 2 delays. So you can write z power minus 1 in series with the z power minus 1, or here itself we can make it as z power minus 2. So 2 delay elements to produce z power x of n minus 3. Now the coefficient for x of n minus 3 is minus 2 by 13. The coefficient for this is x of n minus 2. So here we don't have a coefficient, the coefficient is 0. So therefore there is no connection. Then again to generate x of n minus 5, 2 delay element, that is x of n minus 4, and one more delay element to get x of n minus 5. And the coefficient for x of n minus 5 is 1 by 32. Now if you are identifying the same equation number 2, so we have how many adders? 1, 2 and 3. So 3 adders are required to connect this in terms of realization circuit in direct form 1. Now this is added with one adder, right? So this expression is 1 by 32 x of n minus 5. Now again it is added with this term. Now this term is having a minus 2 by 13 multiplied by x of n minus 3. Now this is again added with one more adder to get our final output. So this output is nothing but 2 into x of n. From this line we got minus, so this line will got 1 by 5 into x of n minus 1, 1 by 5 x of n minus 1. Next from this line addition minus 2 by 13 x of n minus 3, and the last term which is 1 by 32 x of n minus 5. So this equation is same as the equation number 2. To realize this equation, the difference equation, we have used the delay elements as well as the adders and coefficients to multiply with the required terms, that is multipliers are required. So this is for equation number 2. Now substitute equation number 2 in equation number 1. If I substitute in the equation number 1, then y of n becomes minus 1 by 8 y of n minus 1. So observe that we are not at all changing the difference equation, right? So just we are taking for realization of the IIR filter, we are considering one intermediate input or output, that is w of n, and we are substituting the same in the y of n. Then plus 5 by 8 y of n minus 3 plus 1 by 10 y of n minus 2, and the remaining part will be substituted by w of n. So give it as equation number 3. Again for this equation we have to realize the circuit. Then what is the input for this circuit? W of n is the input. What is the output? Y of n is the output. Now the coefficient for W of n is 1. So here nothing is there. If it is nothing is there, you have to consider the coefficient as 1. Then if you are identifying the expression, difference equation, the output is delayed by 1 sample, here 2 samples, 3 samples and 5 samples, right? So first output will be delayed by 1 sample, then we will get y of n minus 1. The coefficient for y of n minus 1 is minus 1 by 8. Then to generate y of n minus 2, again it is delayed by one more sample, that is y of n minus 2. Then the coefficient for y of n minus 2 is 1 by 10. Next, to generate the y of n minus 3 with the coefficient, again it is delayed by one sample, that is y of n minus 3. And the coefficient for this is 5 by 8. Now, to generate the last term, this y of n minus 5. So this y of n minus 3 again delayed by 2 samples. Therefore, it will generate y of n minus 5. Then the coefficient for this y of n minus 5 is 1 by 10. Now, in the expression we have 1, 2, 3 and 4. 4 adder circuits are there. So therefore, first adder to connect this, then second adder, third adder and fourth adder. So remember, always if w of n, in the previous case it was the output, that's why input is directed towards the output side with the arrow mark. Now here also the w of n is input here. So input always has to be directed towards the output side. Depending upon the expression, if input is delayed, input side you have a delay element. Suppose if output is delayed, output side you have a delay elements, right? Now this y of n is, if you are adding all these multipliers with the adders with the delay elements, you will get the same expression. This is the realized equation number 1, that is overall circuit. So whatever we have drawn for equation number 2 as well as for equation number 3, the combined circuit is a realization for the given difference equation. Now if I draw the combined circuit, first input is x of n and the output is y of n. So same circuit we are combining with w of n. So w of n is the output here. At the equation number 3, w of n is the input side. Then input is delayed by z power minus 1, that is x of n minus 1, and the coefficient is, here it is 2 and here 1 by 5. Again one more coefficient. So this is a combined circuit which is realized circuit in the direct form 1. So combine both the circuits to get the final direct form 1 realization. Next, at the output side, suppose in the expression, if y of n minus 4 also there, then you have a connection from this point. Here if it is x of n minus 2 are there, then you have a connection. Because here the coefficient is 0, we are not at all considering this as a line for the connection line to the output side. Therefore, this is the final direct form 1 for the given difference equation. Now, how many delay elements are there? Here 1, 2, 3, 4, 5. So therefore, m is equals to the number of delay elements at the input side. And here also 1, 2, 3, 4, 5. So n also the number of delay elements at the output side, that is 5. And the total number of additions required is equals to m plus n formula, that is 10. Next, the number of memory locations required for direct form 1 is 5 plus 1, that is 11 memory locations are required to generate this factor, right? So therefore, the number of additions and number of multiplications required is 10, as well as the number of memory locations required for direct form 1 structure is 11 memory locations. So now we will compare the same with the direct form 2 structures. Now for direct form 2 structure, so write down the first given expression, that is y of n is equals to minus 1 by 8 y of n minus 1 plus 1 by 10 y of n minus 2 plus 5 by 8 y of n minus 3 plus 1 by 10 y of n minus 5 plus 2 into x of n plus 1 by 5 x of n minus 1 minus 2 by 13 x of n minus 3 plus 1 by 32 x of n minus 5. Give it as equation number 1. Now apply the Z transformation to get our transfer function. So transfer function is y of z by x of z. So apply Z transform on both sides. Whenever you are applying the Z transformation on both sides, y of n becomes y of z in terms of z domain. So y of n minus 1 becomes, the delay is z power minus 1 into y of z. Suppose y of n minus 5, then the delay is minus 5, z power minus 5 into y of z. Similarly, on x of n, if I apply the z transformation, x of n becomes x of z. Then x of n minus 5 if I apply, that will becomes z power minus 5 into x of z. Now applying the same on the expression number 1, then we will have y of z is equal to, so constant not at all affecting the z transformation. If we are applying the z transformation also, constant will be constant itself. So this is our linear constant coefficient difference equations. Then z power minus 1 into y of z plus 1 by 10 z power minus 2 into y of z plus 5 by 8 into z power minus 3 into y of z plus 1 by 10 z power minus 5 into y of z. Similarly, 2 into x of z plus 1 by 5 z power minus 1 into x of z minus 2 by 13 z power minus 3 into x of z plus 1 by 32 z power minus 5 into x of z. So this is our z transformation. After applying the z transformation, we have a common factor, that is y of z, which is common in both the sides, as well as x of z. Now take y of z as a common and x of z as a common to get our transfer function. If I take y of z as a common, getting to right hand side, then 1 plus 1 by 8 z power minus 1 minus 1 by 10 z power minus 2 minus 5 by 8 z power minus 3 minus 1 by 10 z power minus 5. This is from output. Similarly, if I take the input side also as a common x of z, then I have a constant 2 plus 1 by 5 z power minus 1 minus 2 by 13 z power minus 2 minus 3 plus 1 by 32 z power minus 5. Now y of z, take the x of z as a left hand side and give this to right hand side. So 2 plus 1 by 5 z power minus 1 minus 2 by 13 z power minus 3 plus 1 by 32 z power minus 5 divided by 1 plus 1 by 8 z power minus 1 minus 1 by 10 z power minus 2 minus 5 by 8 z power minus 3 minus 1 by 10 z power minus 5. Now the same y of z and x of z, so let us multiply and divide by w of z. Now in this factor, y of z by w of z always consider as the numerator value. And first term I am equating with the only numerator, and second term I will equate it to denominator value. So this is numerator. This first function I am equating with w of z by y of z by w of z, and numerator value I will equate it to w of z by x of z. Now cross multiply on both sides. So this is divided by 1, right? So if I cross multiply, then y of z becomes 2 into w of z plus 1 by 5 w of z into z power minus 1 minus 2 by 13 z power minus 3 into w of z plus 1 by 32 z power minus 5 into w of z. Now apply the inverse z transformation on both sides. If I apply the inverse z transformation, generally for z transformation, for y of n, if we apply the Z transformation, we will get y of z. Now, if you are applying the inverse Z transformation on y of z, it will becomes again y of n. In the same way, y of n is equals to 2 into w of z becomes w of n. Next, we have 1 by 5 into w of n minus 1, then minus 2 by 13 w of n minus 3, in the last term 1 by 32 w of n minus 5, 1 by 32 w of n minus 5. So give it as equation number 2. Now this expression, we are designing the circuit structure we are drawing using the direct form 2. Now what is the input here? The input is w of n and the output is y of n. If you are identifying the input is delayed or the output is delayed, input is delayed, w of n minus 1, n minus 3, n minus 5. Now the coefficient for w of n is, that is 2. Then first it is delayed by one sample to get w of n minus 1, and the coefficient is 1 by 5. And second, it is delayed by 2 number of samples. So directly I am writing here z power minus 2 to generate w of n minus 3. Again to generate w of n minus 5, delayed by 2 number of samples. And the coefficient for w of n minus 3 is minus 2 by 13, and the last one is 1 by 32. Now same, we have the adders to connect the available terms with the output term. Now this output we are getting as 2 into w of n plus 1 by 5 into w of n minus 1 plus minus 2 by 13 into w of n minus 13 plus 1 by 32 into w of n minus 5. So this is first realization using the direct form 2. Now consider the w of z by x of z is equals to the denominator factor. The denominator factor is 1 by 1 plus 8 into z power minus 1 minus 1 by 10 z power minus 2 minus 5 by 8 z power minus 3 minus 1 by 10 z power minus 5. Now again cross multiply on both sides. If you are cross multiplying, x of z is equals to w of z plus 1 by 8 z power minus 1 into w of z minus 1 by 10 z power minus 2 into w of z minus 5 by 8 z power minus 3 into w of z minus 1 by 10 z power minus 5 into w of z. Now apply inverse z transform on both sides. Then x of z becomes x of n is equal to w of n plus 1 by 8 w of n minus 1 minus 1 by 10 w of n minus 2 minus 5 by 8 w of n minus 3 minus 1 by 10 w of n minus 5. Now input is x of n and w of n is the output. So let us consider w of n and remaining all these factor move it to left hand side. Then we have x of n minus 1 by 8 w of n minus 1 minus 1 by 10 w of n minus 2 plus 5 by 8. So this is also plus w of n minus 3 and plus 1 by 10 w of n minus 5. So give it as equation number 3. Now this expression we are designing the circuit again. Now again realize the circuit for the equation number 3. Equation number 3, the x of n is the input and w of n is the output. The coefficient for x of n is 1, and if you are identifying, only w of n is delayed by number of samples. So first, to get w of n minus 1, it is delayed by first sample, that is w of n minus 1. The coefficient for w of n minus 1 is minus 1 by 8. Next, again to get w of n plus 2, it is delayed by one more sample, we will get w of n minus 2. The coefficient for w of n minus 2 is 1 by 10. To get n minus 3, w of n minus 3, the coefficient is 5 by 8. Again, the last one, w of n minus 5, the coefficient is 1 by 10. Now all these are added by the adder circuits to get our final expression, that is equation number 3. So remember, always input has to be directed towards the output side, and these are arrow marks because the output is feedbacked to input. That's why the arrow mark is like this. Now we have drawn the individual circuit for both the expression. Now combine both the circuits to get the direct form 2 structures. So this is expression number 3. Now from the above circuit we have w of n minus 1, the coefficient is 2. Next coefficient is 1 by 5. Then w of n minus 3, that is minus 2 by 13. W of n minus 3 minus 2 by 13. Then w of n minus 5 with the coefficient 1 by 32. 1 by 32 the coefficient. All are being added by the adder circuits. So this is the direct form 2 structure for the given difference equation. Now here w of n minus 2, we don't have a connection. Similarly w of n minus 4 also we don't have a connection. Suppose in the given expression, if these terms are also available, then you have to use this term with one more adders. And coming back to the number of adders required is 5 plus 5, that is 10. And the number of memory locations are, formula is maximum of m comma n. The maximum of 5 comma 5, that is 5. Alright? So 1, 2, 3, 4 and 5. So therefore, the number of memory locations required in direct form 2 has been decreased from 10 to 5. That is the advantage of this direct form 2 structure. The number of memory locations requirement is less. If memory requirement is less, it is less in construction. If delay elements are less, then complexity will be reduced. The circuit will give fast output. These are the advantages of direct form 2 structure.